Assalamualaikum warahmatullahi wabarakatuh. My name is Shafiqah binti Abdul Ghafur. My metric number is B07171040. I am from 4BMMH S1/1. My supervisor is Puan Norain binti Mota. My project title is Development of Food Plastic Composite WPC by using empty fruit bunches EFB and polypropylene PP for indoor unit housing of air split unit air conditioner. So we are going through 5 parts: introduction, literature review, methodology, result and discussion, conclusion and recommendation. The first introduction. So background study. Air conditioner is a device or machine that handles air in a fixed, usually closed area through a cooling process in which warm air is removed and replaced with cooler air. To increase the comfort of the occupants, air conditioning is the process of removing heat and moisture from the interior of an enclosed room. This process is most commonly used to build a more comfortable interior, usually for humans and other animals. It is often used to cool and dehumidify room filled with electronic heat producing machines such as computer service, amplifier, and store certain objects such as artwork. So this is the K chart of this project. So the problem statement for this project is the world right now facing the result of humans' waste, especially plastic. The housing material that being used for indoor split unit system currently using plastic, and it is non-biodegradable. So it will harm the environment. So the objective of this project is to develop an optimum empty food bunches EFB and polypropylene PP composite as a housing material for indoor split unit air conditioning system. And second, to analyze EFB and MPP composite in terms of material strength, which is modulus of elasticity, swelling test, and biodegradability. So scope for this project is to analyze the analyze is only to ensure the material strength so that it can hold a suitable weight for indoor split unit system. Second, limited only to split unit system type, and to be more precise, it is only for residential indoor split unit housing. These are the percentage of the sample, which is 3 samples for each percentage. It start from 100% of PP, 0% of EFB, all through the 50% of PP and 50% of EFB. So literature review. So Altunta said that the lignocellulosic filling used in the wood plastic composite WPC is easily available and less lower resin costs, improves stiffness and dimensional stability. And Bombelli says that plastic are synthetic polymers derived from fossil oil and are mostly biodegradation resistant. Polystyrene (PS) is durable of thermoplastic, generally thought to be remain non-biodegradable. In fact, PS biodegrading does happen in natural setting, but at a very slow pace, and therefore PS continue for a long period of time and as a solid residue. Next, methodology. So this is the flowchart of this project. So this project we're going through 4 stages. First, the preparation of EFB. Second is the sample preparation of EFB and polypropylene. Third is the physical material strength test, which is tensile test and swelling test. And last but not least is biodegradability test. So the preparation of EFB is first, when you get the raw material, you have to dry the EFB in sun dry for 72 hours straight. And second step is you grind the raw material into approximately 2 mm particles in size. Next is sieving. Small particle of EFB will be screened into the desired size by using sieving machine. Next is the preparation of EFB and polypropylene. First, you weigh the mass of the both composite. Then, when you get the desired mass, which is 58.2 gram each, you mix them together and put it into the plastic container before you put it into the molding. The mold is 130 millimeter times 105 millimeter times 3 millimeter in thick. So, and last you put it the composition in the hot press machine, which is with the temperature is 180 degrees Celsius with pressure of 1 bar for 50 minutes. After 50 minutes, you put it out and put it in the cool press for 10 minutes. Then this is the physical material strength test, which is tensile test and swelling test. So tensile test is apply tensile force pulling to a sample and test the reaction of the specimen to stress. Swelling test is to soak the composite in the distilled water for 2.5 hours and count the difference in weight. And last test is environmental test, which is biodegradability test. It is measuring degradation in soil by loss of mass in the samples for 18 days and get the initial weight and plant them in a poly bag and make sure water the samples 2 to 3 times a week so that the microorganism can live. So result and discussion. So tensile test. As you can see, this is the graph of MOE. MOE is the modulus of elasticity. That means which sample can withstand the most stress. So as you can see here, the higher the fiber, the higher the MOE. So for this experiment, for this project, the highest MOE is sample F, which is sample F is 50% of PP and 50% of EFB. This shows that the elasticity of the composite increase as the fiber increase. The value of the MOE of 50% of PP and 50% of EFB is 751.94 megapascal, while the lowest is 80% of PP and 20% of EFB, with the MOE value 557.6 megapascal. Next, so this is the graph that I said earlier, which is 50% is the highest and 80% is the lowest. Bear in mind that 100% is just the benchmark. So swelling test is divided into two parts, which is weight and thickness. So this is a weight times time graph, which is over time. How much water absorption in the sample. So as you can see, sample E, which is 60% of PP and 40% of PFB, is the highest weight percentage compared to others. This is due to the high amount of fiber in the composition compared to the others. While for thickness, as you can see, the highest is the sample F, which is 50% of EFB and 50% of PP. This might happen because the EFB store the water molecule in their fiber, so that's why it is effect in thickness but not in weight. Next is environmental test, biodegradability test. So we use 18 days to test this testing. So the result is 50% of VFB and 50% of PP is the most decomposed samples between the 6 samples. In just 2.35 of its weight, just in 18 days. This is different from sample A, 100% of PP, and sample B, 90% of PP and with 10% of FB, which is zero decompose. As you can see from the graph, both of the samples is 0, and the highest is sample F. In just 18 days, sample F can decompose 2.35% of its weight, and sample F can decompose completely in just 2 years. Next is a discussion. From all this data, the most optimum sample among all 6 samples are sample F, which hold 50% of PP and 50% of BFB. This is because 50% AFB, this is because sample F is the highest value of modulus of elasticity, which is 751.9 megapascal. Next, sample F also is the highest amount of percentage weight loss in biodegradability tests, with only 2.35% with just 18 days. Sample F have the most water absorption in terms of thickness, with 6.4%, and second high in terms of weight, 10.9%. However, water absorption is not very crucial in the indoor housing material, so we can ignore that. Conclusion and recommendation. So as a conclusion, this project achieved all the objectives that I mentioned earlier, which is to develop an optimum empty fruit bunches (EFB) and polypropylene PP composites as a housing material for indoor split unit air conditioning system. And the second one, to analyze EFB and PP composites in the terms of material strength, elasticity, swelling test, and biodegradability. Then it is focused on biodegradable of the composite as well as the strength of the composite. So the current air conditioning housing can be replaced to more eco-friendly and did not give harm to the environment. So the recommendation for future development is can use treatment for the raw material before proceed with the mixing process with PP. This is because the raw material without the treatment is consists of cellulosic, which can affect the material strength. Next, can use a binder so that the combination between EFB and PP can bind closer. Binder works as a glue, so the more the glue, the closer the EFB and PP can bind. Next, use another method instead of hot press and normal mixing. Can use injection molding. Injection molding injection molding machine, it's have hot press and mixing in itself, so it can reduce the time consuming to produce this product. And last but not least, longer the time for biodegradability test, and use more than one sample so that they can see various of result. Various of result can make the decision for the product more accurate. So this project has so much potential for a better future and good development in indoor housing air conditioner. Potential for this project is to be applied in residential indoor split unit housing air conditioning system. Thank you.